Okay. Hello, we'll get started in just a minute. Okay, I've got 4 o'clock now. So as soon as we get a dog off my lap, we'll get going here. The primary thing today is we're going to review for exam 2, which is Wednesday. I'll talk about that in a minute. Lots going on in this class. On things other than the exam, please remember that project 1 is due tonight by midnight. I understand, some things can happen. I've got a couple of people I've already granted extensions to. Please try to finish today, but if you have to have an extension, let me know. I will consider and grant you an extension. I will let you know now that I will not go beyond Wednesday, the 14th on Project 1. I can grant you at most an extension till Wednesday night. If it comes to that, I've got people with family issues that have to be addressed. I understand that. So let me know, but please try to finish it tonight. If we let you go beyond Wednesday, the 14th, bluntly, you're going to fall way too far behind, and that's going to be a problem. So do the best you can, get it in by then. Please do the best you can to finish by tonight so you don't have to worry about it during the exam or anything else. But if you absolutely have to have an extension, let me know. We'll see what we can do. Project 2 is out. I have posted it on GitHub. There's a new repo on GitHub for Project 2. I have also posted it on Blackboard. You can get the material from either site. It's identical in both places. If it's not, let me know. We need to fix that, but it should be the same. If you get it from Blackboard, it will look like this. You'll see a heading called Project 2 Description and Data Files. There is a PDF that provides the description, and then there are 3 data files, which are comma-separated value, or CSV files. Briefly on Project 2, what you're going to be doing, it's a little bit different from the majors in that this is something that is more straightforward in terms of what it does and why it's useful. What you're going to do is build a student records management system. Okay, these 3 CSV files are obviously fake student records for my class, for semesters that haven't happened yet. If you download them, as I said, because they're CSV, you can open them automatically in Google Sheets, in Excel, or in Apple Numbers. They look something like this. So get that out of the way. Fall 20, obviously, as I said, they're fake numbers. No student privacy was violated in this. Fall 2022 contains a student record of a bunch of Nobel Prize winners in physics and chemistry. You should recognize names like Werner Heisenberg, Albert Einstein, Marie Curie, Hawking, and the like. So these are their grades in the class. The other 2 semesters, one of them is a bunch of characters. Oops, I opened the same thing twice. One of them is a bunch of characters from Game of Thrones, and the other is the members of the U.S. women's national soccer team at the time when I created this file. So basically what you're going to do is you're going to read in the CSV files. The instructions talk about you've got lines that really don't matter that you want to throw away. So we've talked in lecture about how to do that. Then you've got the rest of the file. Now, I'll warn you, some of the files actually have a couple of extra blank lines at the end of them. These are CSVs, you're reading them in. You can read in the entire file and then split on new lines. You can use read lines to read in a line at a time. I don't specify which you have to do. Read in the file, split it up. And if there are extra empty lines at the end of the file, you have to get rid of them. That's just a little exercise for you to learn to deal with files. So you've done that. You now have 3 two-dimensional lists. And oh, by the way, you have to convert, remember, in a file, everything gets read as a string. You have to convert these numbers to integers because you're going to compute a total for the 3 project grades by adding these up, and that means you have to convert to integers to add them up. You're going to insert additional columns for total points, and you're going to calculate whether they got an A, B, C, D, or F. Then you're going to create a user interface that prints out on the screen for the user. What do you want to do? Do you want to look up a student by last name? Do you want to look up a student by, you want to look up a student by last name? Do you want to look up a student by student ID? Again, all student IDs are fake. And the user will tell you which he or she wants to do, and then you want to ask the user, okay, enter the student name or ID. If there is a conflict, in other words, there's 2 different people with the same last name, you'll have to present the user with an option of which one of these do you want. If there's an error, the user enters a name that doesn't exist or a student ID that's not in the database, you have to tell that. And other than that, you will print out the student record, the student results, and said, hey, this student took the class in spring of 2022, and this student got an A, or this student got a B. So that's really what you're doing with project 2, right? It's a matter of going through, reading in file IO, CSV files. It's a matter of doing 2-dimensional list management. It's a matter of doing a user interface, printing to the screen, reading in, fetching records, doing comparison, everything else. So it's something that's, in a sense, more practical than writing your own game. It's less fun, but more practical. So that is project 2. Now, project 2 is due on the 26th. It is due 2 weeks from today. On that day, we will release project 3. So you need to stay on top of this. Understand right now you're busy. You got to get project 1 finished. You got to get the exam. A lot of you are not going to look at this until after Wednesday. That's okay, but stay on it as quickly as you can. So project 2 is out. Sorry. Project 1 is due tonight. Project 2 is out. You can get it from GitHub. You can get it from Blackboard. It doesn't matter. Again, obviously, these are not real student records. You have to read each of the 3 files at the separate 2D list. We talked about how to do that. Do some calculations, which means you need to convert grades from strings to integers, and you have to insert new columns into the list. And then once you've done that, you write a user interface that lets the user search the data. The user may input invalid data, so you're going to have to check it. There may be multiple people with the same name. You're going to have to check it. I think the instructions are fairly clear on what has to be done. As I said, a little bit different tack than Project 1. You're not writing a game. You're doing something that's more obviously useful, but probably much less fun. But that is project 2. All right, so now I'm going to go over the sample exam for exam 2, and then we'll talk about anything else, and we'll probably be done early. As a reminder, the exam is during the class period on Wednesday. So on Wednesday, the 14th at 4 o'clock, go to Blackboard. I will release the exam at about that time. You will have 90 minutes to do the exam. Those of you who have not more than 90 minutes know it, and we'll take care of making sure you have enough time. I will be on WebEx live during the exam to answer any questions you have. If a question is not clear enough, if you think there's a typo, if you're not sure, that's fine. So you do not have to be on WebEx on Wednesday. You can follow along in case there's a question you want to ask or somebody else wants to ask. If you want to contact me privately and don't think WebEx is sufficiently private, I will also be monitoring Discord. So you could DM me on Discord on Wednesday if you have a question or if you want to run something by me or whatever. But the test will happen live during class period on Wednesday. And then beginning next Monday, the 19th, we'll move on to the last part of the class. So Wednesday, regular class time, show up on Blackboard to take the exam. You'll have 90 minutes. and it'll be pretty much just like last time. Let's go over the sample exam. This is pretty much what you'll see. Let's make sure this works. Standard information. Okay, let's go through this. If you have any questions, feel free to ask me, interrupt, stop. I'm going to walk through what they are. Homework 6 actually comes later. Let me double check. If you have been assigned homework 6, don't start it. Let me take a look. Homework 6 in the schedule was actually supposed to come later on. So let me look on it. If you've been assigned it, I didn't think you have, but if you have, don't do anything. Let me know. I will let you know as quick as I can. There is a homework 6, but it's supposed to come later in the semester. Okay. Where can a function be called in Python? We've talked about a function can be called anywhere except on the left-hand side of an equal sign. You can't say something like factorial of number equals blah, 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 blah. So the short answer to this is anywhere other than the left-hand side of an equal sign, you can call it. Yes, you can call a function from the main program. Yes, you can call it from another function defined below it in the code listing. Yes, you can call it from another function defined above it in the code listing. All of these are true. So in this case, the answer to question 1 is all the above are true. If I had reworded it, you cannot call it from the left side. You cannot call it from the left side. So all the above are true. In response to the question in the chat, yes. Homework 6 kind of dovetails with project 3. That's why it's done less. The homework project 3 is released 2 weeks from today on the 26th. According to what I wrote down on my whiteboard here, the last day of class is the 12th of May. That is the day project 3 is due. Project 3 is due the last regular day of class, the 12th of May. And then the final exam is during the final exam time, which I'll have to look up and see what it is. And I had planned to schedule homework 6 in the middle with project 3, but I'll look into that. So that's the plan. Okay, question 2. The following true or false, the following recursive function includes an acceptable recursive case. Remember, with a recursive function, you need a base case. A base case is something that's simple enough to solve straight out. You can just do it. 1 factorial is 1. The first 2 Fibonacci numbers are 1 and 1, something like that. Okay, you then have to have a recursive case, and the recursive case has to be simpler than the original problem. If the recursive case is just the same as the original problem, you're never going to get anywhere. In this case, the recursive case calls the function palindrome word, colon, bracket, colon, bracket, like this, is the same as the original word. So in this case, palindrome of the same word is not an acceptable recursive case. Why is it not acceptable? Because it's not simpler. It's not closer to the base. It is the same original problem. And so what happens is you'll get into an infinite loop. Now, if you haven't run into this yet, consider yourself fortunate. In Python, to prevent infinite loops of recursive functions, Python specifies a maximum number of recursions that you can have running at any given time. Typically, it's 100. Typically, if you have something that recurses more than 100 times without stopping, Python will stop the program for you and say, you clearly messed up. Now, you can modify that. You can change that. But there is a max number of recursions to prevent this infinite loop. This is what you're going to hit with this. The answer to this question is this is not an acceptable recursive case because this is the same problem as the original, and a recursive case must be simpler than the original for it to work. Okay. 3, what is the significance of the file pointer in a file open for writing by a Python program? The file pointer, if you're open for reading, says where we're going to start reading. For writing, it says where the next character is going to be written. Now, I got kind of sneaky in this question in the answers because remember, if you're doing file IO, everything is a string. If you're printing to the screen, you can print an integer to the screen. That's not a problem. You cannot print an integer to a file. You can only print strings to the file. So the answer here is this one, C. It identifies where the next string to be output will be printed. Because it's opened for writing, that means we're going to output so it can't identify the next character to be read because you can't read if it's open for writing. It can't identify where the next integer to be output is going to be printed because you can't print an integer. You can only print strings. So this answer, C, is the correct answer for this question. 4, what did I do? Holy cow. Ah! The wrong thing got uploaded here. I will, hang on a second, give me a minute. I will go back and fix those questions. Question 6, the best way to develop a complex program is to, obviously I've warned you, you're going to have this test as you go. Write a function, test it, move on only when you're sure it's correct. I made it as obvious as I could, but the other answer was not correct. Don't test as you go. Do all your testing at the end because you probably haven't made any mistakes, right? None of us puts bugs in our program. I'm concerned about my next few questions because there are some other things that I put in later. Let's see. Question 7, true or false? A recursive function must have one and only base case. That is false. Okay, remember the function we did on Wednesday when we talked about finding whether something is a palindrome or not. We had 3 base cases. The answer to this, it must have at least one base case, but it can have more than one. So question 7 as worded is false. It can have more than one base cases. Okay. 8. Why is it you can replace an element of a list, but you can't replace an element of a string? That is, if L's a list and S is a string, you can say L sub 3 is 5, but you can't say S sub 3 is a character 5. Okay. Remember, strings are immutable. They cannot be changed once defined. Lists are mutable. You can change them once they're defined. So, because the string may not be long enough, that's false. The string, yeah, it's true that the string may only have one character, but that's kind of a silly answer to this question. Okay? Because strings are immutable, which means they cannot be changed after creation. If you want to change a string variable, you must create an entirely new variable with an assignment to the string. That is exactly correct. Even though I misspelled entirely, I just discovered that. That doesn't negate the answer. The answer is correct. Because lists are immutable while strings are mutable is exactly backwards. This is a trick question. You can actually change both variables by the assignment above as long as they actually have an element 3. Just test that out on pie chart. That's clearly false. The answer here is the second one. Okay. 9. Suppose I have 2 lists defined. One contains the 23 counties in Maryland and the other the 23 county seats. Yes, I left out Baltimore City because Baltimore City is not a county. There are 23 counties in Maryland, each of which has a county seat. Here are the counties in alphabetical order. Here are the county seats in order of county by alphabetical order. These actually match up. The county seat of Allegheny is Cumberland. The county seat of Anne Arundel is Annapolis. The county seat of Baltimore is Towson, and so on. How would you construct a dictionary that contained each county in Maryland as a key and its corresponding seat as its value? Here, this is something I put in the tail end of the lecture on dictionaries. The function zip takes 2 lists and creates a dictionary type object out of them. So we know we're going to need zip. But zip by itself does not create a full printable dictionary. It creates a dictionary type object. So what we're looking for is something that has both zip and dict. So the answer is here. This says take counties and seats, the two lists, zip them together, and then make it a dictionary, and this produces the answer you want. Maryland equals the list of counties, county seats. That will be invalid. That's not a valid operation. This one, again, a little bit tricky, but I explained this in class. Maryland equals zip of counties and seats. Zip does not produce a final dictionary. It produces an object which can be a dictionary. It's not an answer of it by itself. Maryland equals dictionary of zip of counties and seats is what we want. All the above will work. Clearly false, because if you tried this in PyCharm, it doesn't give you what you want. All right, 10. In this case, I've only got the list of 23 counties. How would I create a new list that contained only those counties that started with the letter C? This is a fairly simple one. All I want to do is use a list slice. Remember, a list slice is take certain list elements starting at element X and ending at element Y. Now, we always start counting at 0. So Allegheny is county sub 0. Anne Arundel is county sub 1. Baltimore is county sub 2. Calvert is county sub 3. So I want to start at 3. Carrollton is 4. Carroll is 5. Cecil is 6. Charles is 7. Dorchester is 8. So I only want list element counties 3, 4, 5, 6, and 7. So how do I get that using list slicing? And the answer is this one right here. Counties starting at 3, and remember the syntax of this list slicing. This is the first element I don't want. I don't want 8 because 8 is Dorchester. So therefore, I want to start at 3 and go up and stop and do not hit 8. So this is the correct answer here. Pardon me. This is very close. Excuse me just a second. Pardon me. This is very close, but remember that syntax, I want to stop. If I said 3 through 7, I would not get Charles. I want to list the end of the slice as the first one I don't want. So it's 3 through 8, not 3 through 7. None of the above will work. Well, this clearly works. And 3 colon with nothing gives me 3 to the end. So it gives me everything except these first 3. It gives me Calvert all the way through Worcester is the last one. Okay. So this is the answer. This question is about list slicing. So you will have those 10 3-point questions, either multiple choice or true false. And then we move on to the short answer. The short answer, there's 5 of them. They're worth 5 points each. Now, obviously, true, false, multiple choice, there's no partial credit, right? It's either right or it's wrong, okay? I can't give you 1 point for saying false when it was true. So those are just the 3 points. You get them or not. For the rest of them, I do give partial credit, so try to answer. There's 5 points each. So suppose I have the statement A equals 1, and then later in the same program, I say A plus equals 1. Explain how this works in Python, given that you do know, integers are immutable, and thus the value of A in memory's location can't be changed. Here's the answer I'm looking for. A plus equals 1 causes Python to get a new location in memory and set the symbol table so that A points to that new location. The old location in memory is gone. Nothing in the symbol table points to that anymore. That's what I'm looking for. I'm looking for, because it's immutable, you declare a new location in memory. You do not change the value of the old location in memory. You just get a new location in memory. You store the appropriate value there, 2. and you point the symbol table so that A points to this new location in memory, the old location in memory is gone. You're not pointing there anymore. That's what I'm looking for. You know, any partial credit, if you get symbol table, that's probably worth 3 of the 5 points. The new location in memory, things like that. That's what I'm looking for there. Now, deep copies. We have a one-dimensional list. This is different for two-dimensional. That was your homework assignment. We have a one-dimensional list of types of cars. I want to know what are 2 different ways of making a deep copy of cars in a new list, and this deep copy I'm calling autos. That is, when I'm done with this deep copy, I want to make sure that autos points to different location in memories than cars does. And so when I make changes, that's a typo, it should say changes, not chances, to autos should not result in changes in the original thing, cars. Okay, the 2 ways we've talked about doing this are list slicing. Autos equals cars, start from the beginning and go to the end. Okay, start from the beginning and go to the end. I could alternatively say cars 0 to the end. That works too. It's logically the same, what have you. But list slicing. And the other is the list creation equals list of cars. Taking a list creation creates a new list. That's what I'm looking for. Those are the 2 ways. Give you 3 points if you get one of the 2, 5 if you get them both. Okay. Now, question 13. I've got a dictionary called quarterbacks. These are the quarterbacks in the AFC American Football Conference Northern Division. Okay. Ravens, Lamar Jackson. Steelers, Ben Roethlisberger. Bengals, Joe Burrows. Browns, Baker Mayfield. That's my dictionary. Now, I want to find out if Tom Brady is in this dictionary, and if so, what team he plays for. Okay, so I have to write a little bit of code to figure this out. Okay. Now, there's a number of ways to do it. This is how we showed in lecture. This is, to me, the simplest way. For key in quarterbacks.keys, colon. Key is my index variable. If key equals the string Brady, print quarterbacks sub key. That'll do it. Okay. I just go through, remember, there's no easy way to look for a value and find the key by the, there's no direct way to look at a value and find the key. You basically have to go through each possible key and find the value that matches. You could write code that says if it doesn't match, print false. There's a couple of other things you can do. But this is the simplest way to me. Okay. Okay, let's see if this works. So theoretically, I got a PDF that's a graphic of parts of a function. Come on, work properly. Here we go. That's, hey, how about that? It actually worked. So what I want you to do is tell me what A, B, C, D, and E are. So let's look at this. A is the argument. A is pointing to the X, and if you're not, if I do this on the test on Wednesday and it's not clear to you what I mean, you know, like I said, ask me, Discord, WebEx, whatever. That's why I hang around live for the exams. A points to X, the X is called the argument. So A is the argument, and before I go back and write, B points to number, that is called the parameter. Remember, in the calling where you call, that's an argument. In the function definition, that's the parameter. So A is the argument. B is the parameter. Let's go back and look at our graphic again. C is the function name. This factorial right here, this is the function name. D is the return statement. So C is the function name, D is the return statement, and E points to factorial right here. This is the function call. So what I'm looking for here is that C is the function name, D is the return statement, and E is the function call. And obviously, I would give you one point for each of those 5 answers. Okay. So there's a couple of slides from the function lecture notes that have all these things identified in various colors. But what I'm looking to see is whether you know that in the call, it's called an argument. In the function definition, it's called a parameter. The function name, the return statement, and the function call. Okay. 15. Describe the 2 cases you have to have in a recursive function in order for that function to work correctly. We talked about this before. You need a base case, and that has to be the case you can solve directly without further help. And the recursive case, simpler than the original problem you started on. Here, simpler means closer to the base. This is the thing I'm looking for. The problem statement says describe the 2 cases, so that's what we're looking for as a description. If you just gave me the 2 names, the basic recursive, I'd probably give you 3 points out of 5 on that one because I didn't say name them, I said describe them. Okay, so that's what we're looking for there. So those are the 5 short answer questions. You'll have them similar to that. And again, I do give partial credit. I try to be reasonable with partial credit. So please, please, please don't leave it blank. Answer something. Okay. Now, 16 and 17 are the programming questions. You're asked to write Python code. Again, I give partial credit. They're 10 points each, so don't leave them blank. Give it a shot. 16 says this. Suppose you have 2 files, counties and county seats. They contain respectively the list of counties and the list of county seats in the proper order. They match up. Write a Python program that contains a function that reads in the counties and creates a list of them, and a separate function that reads in the county seats and creates a list of them. So you've got to have 2 functions here, right, and your main program. Then call a function that zips the 2 lists together to form a dictionary and by printing out the dictionary. So you've got to have 3 functions. Okay, tell you right here in the instructions. You have to have this function, you have to have this function, and you got to have this function. Now, they're going to be simple functions, but let's start. When you're writing this code, I know you've got 90 minutes. This is actually not, that doesn't actually take this long. Let's sketch them out. Def, read counties. We'll talk about it, the parameter in a minute. Def, read seats. Def, zip lists. And now my main program, if okay, let's look at the instructions. I have two files, counties.txt and countyseats.txt. I'm going to read them in. Now, you can do this several ways, and I would not be picky in grading this. You can pass the file name as an argument or a parameter to the function, or you can just read it directly. So if I read it directly, I don't actually have a parameter or a parameter in the function def. So this is going to be data equals let's try it this way. Let's open it up with open counties.txt R as county file data equals county file dot read and now split this into a list. So we'll assume that it's properly structured and there's blank space and there's a white space in between each county name. Do I tell you whether there's commas or not? I don't know. I don't tell you what they're split by, so you can assume they're split by white space. You can ask the question if you want. So county list equals data.split return county list. Read seats is almost identical. The only thing you do is change the name. Seats.txt county seats. R as seats file data equals seats file dot read seats list equal data dot split return seats list. Okay. If name equals main. Okay. Counties equal read counties. Seats equal read seats. Now I have my two lists. Now I just have to call them. D equals zip lists of counties and seats. And so now all I have to do, print D, writing the text for zip lists. My two parameters have to be counties and seats. Get rid of that blank space. Return dict of zip of C and S. This is all you need. And that would be fine. And you can have anything changed you want. You can have extra, you can have explanatory, you can have whatever. In terms of comments, again, I'm personally grading this as long as you think I can understand what you're doing. Yeah. The only place you have to have a comment is if you want to explain to me what you're doing so that if there's an error or something, I'll give you partial credit, or so if you think I might misunderstand you and deduct points when I shouldn't. Yeah, that's the problem. The second programming question is recursive, and you can plan on this on Wednesday. One program will be, you'll have to write, will be recursive, and the other will not. I have to debug them. I have to check my typos. Write a Python program that prompts the user to enter the integer and read it in. You can assume that the user actually enters a positive integer. No input validation is needed. call a recursive function that sums the digits in the integer. For example, if the user inputs 1, 2, 3, 4, 5, your recursive function should return 15 because 1 plus 2 plus 3 plus 4 plus 5. Print out the value that was returned. So the only thing I'm looking for here is you have to write this function. Of course, you can do this iteratively. I'm not going to let you. You have to define the function. Def sum digits is your recursive function. Number equals input or int of input enter a positive integer sum digits number. Okay. Let's say answer equals sum digits number. Print the sum of the digits in your number is. Answer. Okay, so all we have to do is write the actual recursive function. Straightforward. Base case. If there's only one digit, then we know that the sum of that one digit is the digit. So if number is less than 10, return number. Okay? Think about it, okay? If you have a one-digit number, the sum of all the digits is that number. So if the number is less than 10, return the number. Otherwise, what we're going to do is we're going to take one digit off of this, divide by 10, and recursively call. So in other words, if we have, for example, 1, 2, 3, 4, 5, we're going to chop off the 5, get the sum of 1, 2, 3, 4, then add 5 to it. This is the pseudocode. This is logically what we want to do. Okay, and so now how much explanation, how much code I write here is how clear I want to be. Let's say I want to be very clear and I'm going to write some extra code. So I'm going to say that this digit equals number mod 10. This just gets me the last digit. Guaranteed, number mod 10 gets me the last digit in the original number. Now, what I need to do is I need to call the recursive, right? I need to take that number, new num equals number integer divide 10. This gets me the 1, 2, 3, 4, right? This gets me the smaller number. And now I need to recursively call the function I'm just going to call it temporary equals sum digits of new num answer equals this digit plus temp return answer. So that's what you want to do. So like I said, I've written this code to be very inefficient. It has a number of extra lines. You could combine a lot of these things into simpler statements, and that's perfectly okay. If I understand what you're doing, you get full credit. If I don't understand, I'll give you as much partial as I can. So if you want to make it perfectly clear to me what you're doing, something like this, here is the pseudocode of what I'm doing. This is my algorithm, and this is how I do it. This first statement gives me this chop off the 5. The second statement gets the 1, 2, 3, 4. The third statement gets me the sum of those. The fourth statement does the add 5. So basically these 1, 2, 3, 4 statements do the things in this line. And that's the answer for 17. So that is the sample exam. That is in terms of number and type of problems you're going to have. What you'll see on Wednesday. Again, this has to be cumulative because I can't let you forget, what an integer variable is and how a for loop works and how it's different from a while loop and so on. But the emphasis on the exam is going to cover recursion, which we just covered, dictionaries, 2D lists, mutability, file I/O, and functions. That's the focus of the exam. Okay, again, you can't forget what an integer is. You can't forget what integer division and modular arithmetic are. You can't forget the order of precedence that you have to do multiplication before you do addition. I mean, the program's just not going to work if you don't remember that. So it's cumulative in that sense, but this is where the emphasis is. So again, Wednesday, 4 o'clock, class time, log on to Blackboard. I will make the test available to you at that time within a minute or two. You will have 90 minutes from the time I make it available. So if something happens and I'm a few minutes late, it's not going to penalize you. You get 90 minutes from that time. And I will be on WebEx and also monitoring Discord if you have any questions. I prefer, unless you really want to talk to me privately, I prefer you come on WebEx if you have any questions. But if you want to ask privately on Discord, that's fine too. And that's another 75-point exam. And then you can get going on project 2, which is available. So I am done with tonight's material. If anybody has any questions, I'm happy to answer them. Otherwise, I will see you on Wednesday for the exam. If you need an extension on project 1, let me know. If you've got a reason, I can let you go till Wednesday. I cannot let you go past Wednesday night on project 1. Okay. Any questions? And I'll let you know about homework 6 when I figure it out. Like I said, I plan to do it in early May. You'll have homework 6 the first week in May was the plan. I'll double check that. So, okay. Any questions? If not, I will see you on Wednesday. I'm going to stop recording. So go ahead. Yes.
Quick question, Professor. I just wanted go over the lecture and whatnot, but I mean, it was good, but it'll be post. I know I always rewatch and stuff, but it's